Okay, intermediate chapter 7 concludes with word problems using linear systems. So word problems can involve multiple unknowns, multiple variables. Despite that, we can usually use systems of equations to solve them. So we're going to read the problem, assign variables to our unknowns, try to find the two equations that we're going to use, solve the system, state the answer, and try to state it in words to make sure it makes sense. So we'll start with some basics. The sum of two numbers is 112. The difference between them is 28. Find the numbers. So we got two numbers. We'll call x and y. Okay, so we know the sum is 112, so x plus y equals 112. And the difference is 28, which means x minus y equals 28. I'm going to use elimination for all these when possible. When I add these two equations together, I get 2x equals 140 divided by 2. X is 70. Plug it back in. 70 plus y equals 112. Subtract 70. Y is 42. So my two numbers are 70 and 42. Not too bad. So we'll leave number 2 for you. Let's continue. Okay, the perimeter of a building is 132 feet. The length is 4 feet longer than the width. Find the dimensions. Okay, so for the building, we'll have a length and a width. So the perimeter of a building is 132. So we're talking about roughly a rectangular building. There are 2 lengths and 2 widths. So 2 length plus 2 width is 132. Length is 4 feet longer than width, so L equals W plus 4. Normally I would use substitution, but this naturally sets up really well for substitution by just plugging in. So 2 times W plus 4 plus 2W equals 132. That's 2W plus 8 plus 2W equals 132. Combine my like terms. 4W plus 8 is 132. Subtract 8. 4W is 124. So W is 31. Now it says length is 4 more than W, so length equals 31 plus 4, which is 35. So the dimensions of my building are 31 by 35 feet. Number 5 is another classic example of this type of problem. A motel clerk counts his $1 bills and $10 bills at the end of the day. He finds out he has 37 bills that totaled $163. How many of each bill does he have? So X be the $1 bills and Y be the $10 bills. What we know is the number of bills, X plus Y, is 37. Now we also know the value. So every X counts as 1. So it's 1X. But every y counts as 10. So 1x plus 10y equals 163. Okay, so to combine these two, though, I'm going to need to multiply this by -1 so that I have the opposite. So -1x minus y equals -37. When I add these together, I get 9y equals 126 divided by 9. Y is 14. Okay, so there are 14 $10 bills. Now we know x plus 14 equals 37. Substituting the 14 back into the original. Subtract the 14 to get x is 23. That means he has 23 $1 bills and 14 $10 bills. Not too bad. Another example of this is the mixture problems. A pharmacist needs 100 liters of 50% alcohol solution. She has 30% alcohol solution and 80% alcohol solution she can mix. How many liters of each will she need to make her mixture? Okay, so this is kind of complicated. we know that if we call the 30% alcohol solution and the 80% alcohol solution x and y respectively, 30% really is 0.3, so 0.3x plus 0.8y needs to make a 50% solution at 100 liters. Furthermore, we know that just generally x plus y is going to have to be 100 because we know there's going to be 100 liters total. So what is this really? What's 0.5 of 100? 50. So we've got 0.3x plus 0.8y equals 50. X plus y is 100. To clear the decimals, I'm going to multiply everything by 10 there. So that'd be 3x plus 8y equals 500. I'm going to multiply this equation by -3. -3x minus 3y equals -300. I'm going to get, when I add these together, 5y equals 200. Divide by 5. Y is 40. So that's 40 liters of the 80% alcohol solution. I know x plus y is 100. When I plug it back in, that means x is 60. So 60 liters of 30% and 40 liters of 80% is my answer. This one is kind of tricky overall. Probably one of the harder word problems you can encounter. Let's do one more. Two trains are 510 miles apart. They pass after 5 hours. One train is going 28 miles per hour faster than the other. How fast are the two trains going? Okay. So if two trains are passing each other after 5 hours, and they're 510 miles apart, we know if they're going towards each other, okay, we're assuming they're going towards each other, otherwise it would be impossible. If they're going towards each other, we know that their speeds are working together. So we have x plus y, 5 times x plus y equals 510. And we know that x equals y plus 28. It's going a little bit faster, 28 miles per hour faster. So really this helps us reduce to x plus y equals 102. If I move the y over here, it's x minus y equals 28. When I add these together, I get 2x equals 130, so x is 65. So that means our faster train is going 65 miles an hour. That means our slower train is 65 minus 28, which is 37. So the trains are going 65 and 37 miles per hour, respectively. I said that'll be our last one, but we can do one more. A plane travels at 540 miles per hour with the wind and 380 miles per hour against the wind. How fast does it fly without any wind? So we'll let x be the plane, y be the wind. When it travels with the wind, they're working together. X plus y equals 540. When they're working against the wind, x minus y equals 380. So again, we add these. 2x equals 920 over 2. X is 460. Now normally we solve the rest. However, it just wants how fast does it fly without the wind, which is our plane speed, which is x. So the only thing it's asking for is x, which we already got our answer. So the plane travels 460 miles per hour with no wind. And that is all for 7.7.